For scientific work, room temperature is taken to be 20 degrees Celsius to 25 degrees Celsius. Room temperature. And to convert temperature from degrees Celsius to Kelvin, you simply add 273 to make it Kelvin. While absolute zero is the minimum or lowest temperature that is possible. And the only metal that is liquid at room temperature is mercury. This is the only metal that is liquid at room temperature. The only non-metal that is liquid at room temperature is bromine. Bromine. Why the most reactive metal is francium, the most reactive non-metal is fluorine. Quantum numbers, take note that they describe electrons and not atoms. Meanwhile, N2O is the first anesthetic man ever used, the first anesthetic. The electrolyte used in downcell is molten sodium chloride fused with calcium chloride, CaCl2. Quicklime is calcium oxide, CaO. Quicklime, that is the common name. Slaked lime is calcium hydroxide, CaOH2. This is slaked lime, calcium hydroxide. We have lime water. Lime water is calcium hydroxide in water. When calcium hydroxide is in water or dissolves in water, it becomes lime water. Quicklime, soda lime or caustic soda. So the common name for sodium hydroxide is soda lime, or you can call it caustic soda. Sodium bicarbonate, NaHCO3, this is called baking soda. Look at this, the difference between soda ash and washing soda. Soda ash is Na2CO3. This is soda ash. What about washing soda? Washing soda is Na2CO3 when it is .10H2O. So dissolved in water or with water of crystallization, soda ash becomes washing soda. This is bleaching powder, CaClO2. You can also call CO2 dry ice. Yes, it can be dry ice. I think in this form of dry ice, we can use it as a refrigerant. Yes, in your refrigerator and air conditioning system. You can call sodium chloride common salt or rock salt. Yes. Hello, I am Flash Isaac, and today I'll be taking you through key points in chemistry for your examination. Now, if you've been following my chemistry classes, you notice that sometimes I teach a topic as a whole, that is from beginning to the end. Organic chemistry, matter, this, gas law, I teach everything. In some cases, I solve past questions. I can just pick an exam and say, okay, let's solve past questions in chemistry for this examination. In some cases, I solve likely questions. I form questions and I solve. So feel free to check out my chemistry playlist so you don't miss out any of my chemistry videos. I will share a link to that. But what I shall do today is give you points in chemistry. So I just look for highlights, important things you need to know in chemistry for it to be in your mind so that anytime you are asked or you say something like that, you really like it. So it's for fun, for enjoyment, for revision, for learning. So let's begin. And if you like what you are seeing, feel free to subscribe for even more. Now, we can't talk about points in chemistry without the definition. So that is one of the most important things you should know in chemistry. Chemistry is the study of the composition, properties, and uses of matter. So you see, so chemistry talks about the composition, property, and uses of matter. And matter, on the other hand, is anything that has mass and occupies space. So almost everything in the universe is matter. This marker, the marker board, the air we breathe, we humans, chair, stone, they are all matter. So matter is not a special thing you just cram. No, there are things you should appreciate around. And the opposite of matter is energy. This is why energy is often referred to as antimatter. Antimatter. Matter can exist in different forms or in different states, which are the solid state, the liquid state, and the gaseous state. Now, the difference between solid, liquid, and gas is simply the force. So, force of attraction between molecules is actually what makes the difference between solid, liquid, and gases. Like in solids, the force of attraction between the molecule is very, very strong. So this gives them definite shape, definite volume. Okay? But for liquids, they don't have definite shape because the force of attraction between molecules is loose compared to liquid. This is why if you have a container like this, when you pour water on it, the water bends to take the shape of the container. While in gases, the force of attraction between the molecule is so loose that you can even cut gas. For example, smoke. You can use your hand to cut across smoke without it even staining your hand initially. So gases, they can be compressed. Now, in this state of matter, there is something called change of state. So you can change matter from one state to another. For example, water in liquid form, when you freeze it, it becomes solid. Put it in a freezer. So matter has changed from liquid to solid, and the process is called freezing. Then this solid, it can melt and go back to liquid. So from solid to liquid is melting. Then you can boil this and it becomes gas. It begins to evaporate. So from liquid to gas is evaporation. In some cases, matter can move from solid to gas without passing to the liquid state. Meaning you can keep something here, it will just go to gas. It won't wet your cloth or the medium. In that case, we say it has sublimed. That is sublimation. Ammonium chloride and camphor, they sublime. What is the opposite of sublimation? Matter changing from gas directly to solid. It's called deposition or resublimation. Example is water vapor. You see in very extremely cold region, you just look at your wall or window. You see water vapor comes, it enters. Before you know, it has blocked from gas directly to liquid. It has blocked without passing through the liquid state, gas to solid. So we say that is what? Deposition. So now matter is made up of atoms. Atom is the smallest part of a substance that can take part in chemical reaction. That definition is okay because we shall look at atomic theory later based on key points. Now this atom in turn is made up of subatomic particles, which are electron, proton, and neutron. This is the nucleus inside the atom. Proton and neutron are inside the nucleus, while electrons revolve around the nucleus. Proton and neutron are inside the nucleus, electron revolves around the nucleus. Electron is negatively charged, proton is positive, and neutron has no charge. So atom is balanced because the negative and positive charge of electron, they are equal and opposite, so they cancel out. So this makes atom to be balanced or maintain neutrality. And there's what they call atomic mass, atomic number. In chemistry, we have elements, compounds, and mixtures. Element is a substance which cannot be split into simpler form by an ordinary process. Examples of elements are hydrogen, aluminium, zinc. So they are pure substance. Yes, because given a substance can be pure or impure. If a substance is pure, it is called an element. If it is impure, it is either a compound or a mixture. So elements, I gave example. While compound is composed of two or more elements combined together chemically. So when two elements react chemically, they form compound. Like this is sodium, this is chlorine, this is hydrogen, this is oxygen, this is hydrogen, this is sulfur, this is oxygen. If sodium and chlorine react, they can give you sodium chloride. This is salt. This is a compound because a new substance is formed, there is reaction, and the characteristic of sodium chloride is different from that of sodium separately and that of chlorine. What about hydrogen? 2 molecules of water and 1 of oxygen. They form water. The property of water is different from the property of hydrogen alone and that of oxygen alone. So in compound, they act as one, the result. But mixture, okay, here we can say H2SO4, tetraisosulfate 6. It can be said H2SO4, tetraisosulfate 6 acid. But mixture contains 2 or more elements or substances combined physically. There is no reaction. For example, air is a mixture of nitrogen, oxygen, gases, and a lot of particles. So each of these particles, they retain their own properties. There is no common property. So that is mixture. Even blood is a mixture. So we have a lot of mixtures around. Gary and sand, those are mixture. Salt and water, you mix them. Crude oil, they are mixture. So we use separation techniques to separate those mixtures. So atoms, they are different elements are arranged in periodic table based on their atomic number. The first atom is hydrogen. So that atomic number is the number of protons. So we have the first 20 elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Those are the first 20 elements. So hydrogen is number 1, helium 2. In that case, we say the number of protons of hydrogen is 1, the number of protons of helium is 2, and so on. So that is the atomic number. While the atomic mass is the number of proton and neutron combined. That gives you the mass of the atom. Some question will say, which of the following contributes greatly to the mass of the atom? Is proton and neutron. Now, if an atom is neutral or for neutral atoms, the number of protons is the same thing as the number of electrons. So the number of electrons can also be atomic number. Remember, these are key points. So like I will share links to the main topics in case you are interested. So this is why I recommend that you watch on YouTube. Now this atom is so important that scientists, they bring out different theories concerning atom almost all the time. So now let's start with Darwin's atomic theory. So let me list them. The first one, all matter consists of indivisible particles called atoms. He said all matter, they contain particles that cannot be divided. These particles are called atoms. That's the first Darwin atomic theory, but it was later disapproved. We found out that we have subatomic particles, which are electrons, protons, and neutrons, which I just explained. And Darwin also says that atoms of the same element are exactly alike. No, that is his theory, but it was disapproved later. They are not exactly alike. There is what we call isotopy, where atoms of the same element can have the same atomic number, but different mass number. We also have isobars. Different mass number, the same mass number but different atomic number. So atoms of the same element are not always alike, like Darwin said. So Darwin also said that atoms can neither be created nor destroyed, although it can change from one form to another, or in a chemical reaction, atom is not created or destroyed. But fine, that is useful in the law of conservation of mass, because in reaction, the total mass here is the same thing as the mass of this plus the mass of this. That is true, but in radioactivity, there is what we call spontaneous disintegration of the nucleus of an atom in radioactivity. So heavy atoms or heavy nucleus, they split in natural radioactivity to form different particles. And when we talk about radioactivity, main particles that are formed are alpha particles, beta particles, and gamma rays. Alpha particles are helium nucleus. So when a particle emits alpha particle, it means this guy is emitted. While beta particles are fast-moving electrons. While for gamma, they are rays. Gamma ray has the highest penetration power, followed by beta particles, then alpha particles. Alpha particles can be stored by a paper. The ray is not powerful. Why this can be stored by aluminum foil, beta particle, this is beta particle, this is alpha particle, gamma. This aluminum foil, why gamma rays can be stored by a lead block. So natural radioactivity is when an unstable nucleus just split, disintegrates on its own, while artificial is when you bombard stable nucleus, you just bombard them to just destroy the nucleus. We call that artificial radioactivity. Then that can also say that when atoms combine, they do so in simple whole ratio. That was also disapproved. Atoms can combine in ratio that are not even simple, with high numbers. The J.J. Thomson's theory is referred to as Plum Bonding theory. He discovered electrons in his cathode ray experiment. J.J. Thomson actually proposed that atom is a sphere of positively charged matter, inside of which electron is embedded. Something like this, positive electron is embedded inside of it. While Rutherford is the father of nuclear physics or nuclear chemistry, he actually carried out a cathode ray experiment where he bombarded electrons like in the gold foil. Some deflected lightly, some didn't deflect, while some returned. So from there, he discovered that the mass of the atom is concentrated in the nucleus. So you will see all that in the full video like I explained earlier. While Nebel succeeded in bringing out the principle of quantum numbers, he said electrons, they have a particular place they occupy, they have their own orbit. And if you are looking for the maximum number of electrons in any shell, because we have different shells, K shell, L shell, M shell, N, O, and so on. So K shell has maximum of 2 electrons. So the maximum number of electrons in the shell is 2n squared. This is 1, 2, 3, 4, 5. First shell, second, third, fourth, and fifth. Hydrocarbon is a compound that consists of only hydrogen and carbon. That is hydrocarbon, hydrogen and carbon. In hydrocarbon, we have aliphatic hydrocarbon and aromatic hydrocarbon. Aromatic hydrocarbon is a hydrocarbon that contains the ring. It's made up of ring, benzene ring. Benzene is an aromatic hydrocarbon. The formula for benzene is C6H6. Benzene. It has alternating double bond. 1, 2, 3, 4, 5, 6. Meaning 6 carbon, 6 hydrogen. So single bond, double bond, single bond, double bond, single bond, double bond. And carbon is tetravalent, which implies that it can carry maximum of 4 electrons. This one already has 3, this one has 3, 1, 2, 3. So they are all left with 1 to complete to become stable. So H, 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 and H. Remember, the goal of chemical reaction is to achieve stability. So this is also benzene ring. So that is aromatic hydrocarbon. While aliphatic, they can be single bond, straight, or branch. They are not in form of ring. We have saturated and unsaturated hydrocarbon. Saturated hydrocarbon are hydrocarbons with single bond, single carbon to carbon bond. Examples are in alkanes. Alkanes are saturated hydrocarbon. So for example, CH4, this is methane, and it's the most important or most abundant constituent of natural gas. It means 1 carbon and 4 hydrogen. So the general formula for alkanes is CnH2n plus 2. So if you have 2 carbon, the formula will be C2H, 2 times 2, 4, plus 2, 6, H6. That is C2, 1, 2, 3, 4, 5, 6. It is saturated, single bond, and in this type of hydrocarbon or alkanes, the reaction that can occur is substitution reaction. Bromine can just come here and remove hydrogen. Every other part is hydrogen. Remove 1 hydrogen, bromine stays here. Plus the other hydrogen forms HBr with the second bromine. That is C2H3 plus Br2. But on unsaturated hydrocarbons, examples are alkenes and alkynes. Alkenes alkenes, alkynes. This one, they have double carbon to carbon bond. So the general formula for alkenes, CN H2N. If carbon is 2, the alkene becomes C2H4, which is 1, 2, 1 hydrogen, 2, 3, 4. But it won't work because this one has not completed configuration. This is just 2. So let's remove this one here. Let's bring here. So we already have 4 hydrogens, but carbon is tetravalent. It can carry maximum of 4 electrons. This one is carrying 3. This one is carrying 3. 1, 2, 3 electrons. 1, 2, 3 electrons. It's not complete. So double bond is here. So that is alkene for you. This is ethene, methane, ethane, ANE. Alkynes, they are CN H2N minus 2. So if N is 2, C2 H2, 4 minus 2, which is 1. So they are unsaturated. In this one, they can carry out addition reaction. If this is reacting with chlorine, chlorine can come here, break this bond. 1 here, 1 here. The bond has broken to give you chlorine, dichloroethane. So that is summary of hydrocarbon, alkanes, alkenes, and alkynes. Pure substances have definite boiling and melting points. And examples of radioactive substances are uranium, thorium, and polonium. So they disintegrate. These are radioactive substances. And remember, in radioactivity, any radiation is being released. We have particles, alpha particles, beta particles, and gamma rays. And in the periodic table or in elements, an element can be metal, non-metal, or semi-metal or semi-conductor or metalloid. And we have, in electricity, we have conductors, semiconductors, and insulators. Insulators are mainly non-metals. They don't allow the passage of electricity easily. Meanwhile, metal, they allow electricity or current to pass through them easily. But semi-metals or metalloid or semiconductors, they have properties in between that of metal and non-metals. So for a semiconductor, a pure semiconductor is called intrinsic semiconductor. Intrinsic. It does not conduct electricity in its pure form unless we add impurity. When impurity is added to a pure semiconductor, we call the process doping. Doping. So doping is the process of adding impurities to semiconductors. And to dope, we can either use trivalent impurities or tetravalent impurities. Trivalent impurities or trivalent elements are elements that have 3 electrons in the outermost shell, while pentavalent, they have 5. So if this is a semiconductor, let's say it has 4 electrons in the outermost shell. Let's say, okay, 4 holes, this. Then when you dope it with an element with 3 electrons in the outermost shell, that is trivalent. 1 electron feed this hole, the second electron feed this hole, the third electron feed this hole. There is a hole left. So this means this semiconductor, it has more holes than electrons. In this case, we take it is P type. P type. Positive type. But when you are filling it with pentavalent, element with 5 electrons, 1 electron feeds here, 1 feeds here, 1 feeds here, 1 feeds here, another one is here. So we have more electrons than hole. In that case, we say it is N type, negative type. Every nucleus is positive. Radioactivity can also be referred to as transmutation. Energy from the sun is as a result of nuclear fusion, but it reaches us via radiation. This brings us to the methods of heat transfer. Heat can be transferred by conduction, convection, and radiation. In conduction, there is vibration of the medium. There is a material medium For example, if this is a conductor, or this is aluminium, or this is a melter, if you dip one side inside fire or inside hot water, then you hold the other side, you discover that the heat reaches you, so it conducts. So there is a material medium. This is conduction. While radiation is when heat reaches you through a medium, but the medium is not being burnt up. For example, in a cold day, you go to the fire to relax. Okay? So the heat from the fire is reaching you, but there is no medium, nothing is being burnt. We call that radiation. Just like energy from the sun. While in convection, it has to do with a vibration of molecules in cryo. This means in cathode, reduction takes place in the cathode, and in the anode, oxidation takes place in electrolysis. So cathode, reduction, anode, oxidation. And for electrochemical series, you can have this in popular scientists can make a zoo in thin, low, humid country. Mercury, silver, gold. Litosphere consists of rocks and soils, while a sodium hydroxide NaOH is used for making soap. Now the atmosphere or air is composed of 78% nitrogen, 21% oxygen, and 1% of carbon dioxide, water vapor, noble gases, dust, and air pollutants. Remember I told you that air is a mixture, or the atmosphere generally is a mixture. And mixture, they have constituents. So this is a composition of what the atmosphere or air is composed of. The most used chemicals in industries is H2SO4. Then we have fine chemicals. In these ones, they are usually produced in smaller quantities, not in large quantity. And for separation of mixtures, when purity is very important, like in drugs, in medicine, in sugar, we use crystallization. Now for difference in melting point, the difference in boiling point, we use distillation. Where we have fractional distillation and simple distillation. Once the boiling point is far apart, we use simple distillation, like in making of local gin. But when the boiling points are very close, we use fractional distillation. To separate in crude oil, we use fractional distillation to get the constituents of the mixture. Benzene process is used for making steel. Alkenes process is used for making graphite. Nigerian crude oil is referred to as sweet because it has a low sulfur content. Newspaper appear yellow after prolonged exposure to the atmosphere because the bleaching action of SO2 from which it is made has been reversed by atmospheric oxygen. This is why newspaper appear yellow after prolonged exposure. Why palm wine appears sour after long time? This is because the alkanol or the alcohol content in it has been oxidized to form acid. Now allotrope is the occurrence of elements in one or more form under the same physical condition. Like in the same physical state, carbon exists as diamond and graphite. While phosphorus, we have red phosphorus, white phosphorus. That is allotropy or allotropes. Now we have polymorphism. Polymorphism occurs in whether element or substance. If it occurs in elements, it is called allotrope. But polymorphism is the general name for that occurrence. Tin is the only metal that exhibits allotropy. We have a white tin, red tin, and grey tin. So this is the only metal that exhibits allotropy. You may be asked, why is CO2 used as fire extinguisher? It is simple. It does not support burning, and 2, it is denser than air, so we use it as a fire extinguisher. The reason for chemical reactions is to achieve stability. For example, if you have chlorine, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, like hydrogen, helium, lithium, beryllium, boron, carbon. nitrogen, oxygen, fluorine, neon, sodium. Okay, let's call this sodium. Sodium, in this configuration, it has one electron in the outermost shell. Remember I told you that the maximum number a shell can carry is 2n squared, the maximum number of electrons. This is K, L, and M shell. This is the third shell. So the maximum is 18 because n is equals 3. So here is 2 complete, 8 complete, the maximum. So this one has 2 parts, but this first part needs 8, while the other part needs 10. Where you see SPDF, we'll go into that. But let's look at this. This particular one is remaining 8. It needs 8 to complete, but sodium has just 1 in the outermost shell. It becomes unstable and very reactive because it's having 1 electron in the outermost shell. So it can readily give out this electron. Readily. And on the other hand, we have chlorine. Chlorine has this complete 1, 2, 3, 4, 5. Chlorine is number 17. So here is 1, 2, 3, 4, 5, 6, 7. So here we have 17 electrons. Chlorine needs just 1 to complete, to be stable. Then this one has 1 in the outermost shell. Given that this one, it becomes stable. Sodium means chlorine. Chlorine alpha. Please now, give me 1 electron. No, give me 7 electrons. I need 7 more. Give me 7. Let me be fine. Chlorine says to sodium, guy, think about it now. You just need to release 1 to be stable. Once you release this one, you have everything you want. But me, I already have 7. I can't give you 1. You know, now it's easier for you to give me 1. Then sodium say, that's true. Then sodium dashes chlorine. Chlorine just take. As sodium gives, sodium becomes positively charged. When you give out electron, you are positively charged. Chlorine receives it, becomes negatively charged. Then chlorine becomes complete. Sodium becomes complete. So in this case, we say they bonded sodium chloride to form sodium chloride. Compound has been formed. So in this case, it is referred to as electrovalent bonding. When one gives out electron, we call that electrovalent bonding. We have Vander, which are weak forces. We have metallic forces between metals. Now we have covalent bonding. In that case, electron is not giving up. No, they share the electrons. 2 elements or 2 atoms, they come together. They share a particular electron pair. So that is covalent bonding. An acid is a substance that dissolves in water to yield hydrogen ion as the only positive ion, while base dissolve in water to give hydroxy ion OH minus, which is the only negative ion. An acid is a proton donor, while a base is a proton acceptor. The definition is based on Arrhenius, and the second one is based on Bronsted and Lowry. According to Jean Lewis, he said an acid is an electron pair acceptor, while base is an electron pair donor. While HCl, hydrochloric acid, is used to remove rust from iron, H2SO4, tetraoxosulfate 6 acid, is used for drying and dehydration. There is a difference between drying and dehydration. Drying is the removal of water, while dehydration is the removal of the elements of water, either hydrogen or oxygen, OH, H plus or OH minus, any of the elements of water. Hydrogen and oxygen, they are the elements of water. So removing the elements of water is called dehydration, while removing water, H2O, is called drying. Now, how about salts? Salts are compound form when all or some parts of the replaceable hydrogen ion in an acid is replaced by a metal. For example, we have different types of salt: common salt, acid salt, basic salt, double salt. Alum is a double salt. Compound salt, they are normal salts. So that is the standard name, normal salts. You see this? See this H alone. This already shows you that this is an acid salt, right? This already shows you that this is a basic salt. For acid salt, you see H. When you see H in a salt, then that salt is an acid salt because not all the replaceable hydrogen ions have been replaced by a metal. Then if you see OH in the salt, then know that it's a basic salt. Not all the hydroxy ion in the metal has been replaced. So that is it on types of salt. And the characteristics of salt are very efflorescence, deliquescence, and Hygroscopy. Now I explain the properties of salt: efflorescence, hygroscopy, and deliquescence. Efflorescence, these are salts that they release water of crystallization to the atmosphere. If you have washing soda, .10H2O. So if this loses water of crystallization to the atmosphere, that's what we call efflorescence. While deliquescence salts, they absorb water of crystallization from the atmosphere to the extent that they form solution. Or we have hygroscopic salts. In these ones, although they absorb water from the atmosphere, water of crystallization, but they don't form solution. They don't dissolve, they just get sticky. They just become sticky. So that is hygroscopic salt. Haber process is used in the production of ammonia. Vanadium, finely divided iron is used as a catalyst in Haber process. Contact process is used in the manufacture of H2SO4, and the catalyst used is vanadium 5 oxide. That is the catalyst used in contact process. Then we have shapes of molecules. The molecule of water is either V-shaped, angular, or bent, and the bond angle is 105 degrees. For carbon 4 oxide, chlorine, HCl, and these molecules, they are linear, and the bond angle between them is 180 degrees. And in geometry, angle on a straight line, if you have a straight line, then angles are formed on it. The sum of the angle, all these angles in this straight line, they are equals 180 degrees. The sum of angles at a point, you have a point, angles are formed around, everything forms 360 degrees. For a triangle, the sum of angle in a triangle is 180 degrees. Quadrilateral, four-sided shape, 360 degrees. And ammonia is a trigonal pyramidal molecule, and the bond angle is 107 degrees. Methane is tetrahedral, and it has 109.5 degrees. So let's solve this. Let's quickly go through this, and it will be the end of the part 1 of chemistry key points with Flash Isaac. Okay, the first one, Boyle's law. It states that the volume of a given mass of gas is inversely proportional to its pressure, provided temperature is constant. So in this case, to change proportionality to equality, we introduce constant. So we can say equals K, let this be. In that case, V is equals K over P. So PV is equals K. If the volume and pressure changes, it means we have P1 V1 is equals K, P2 V2 is equals K. K is equals K, this is equals this. So P1 V1 is equals P2 V2. So if anyone is missing, they say find the new volume, the new pressure, just make any of them subject formula and solve. And remember, when we are given temperature in degrees Celsius, always convert to Kelvin by adding 27 plus 273. So 30 degrees Celsius to be 30 plus 273 to form Kelvin. Always do that for calculations under gas laws. While Charles law states that the volume of a given mass of gas is directly proportional to its absolute temperature, provided pressure is constant. So similarly, V is equals KT. V1 over T1 is equals V2 over T2. So you can solve for any of them. The volume can be in dm cube. If one of them is in dm cube, the second one should be in dm cube. If one is in cm cube, you can use cm cube uniformly. While Avogadro's law states that equal volume of gases at the same temperature and pressure contain the same number of molecules. So N is proportional to V. So N is equals KV. Now, ideal gas law is made from Boyle's, Charles, and Avogadro's law. Look at how they arrived at this. Look at volume, volume, volume. Right? Now here, there is direct proportionality. Volume is directly proportional to temperature, is directly proportional to number of mole. Volume is inversely proportional to pressure. You see? So, cross multiplying, PV is proportional to NT. Changing to equality sign, we introduce a constant which we call R, the ideal gas constant, to have PV equals NROT. That's how we arrive at this. While Graham's law of diffusion states that the rate of diffusion of gas is inversely proportional to the square root of its density. Now this is heat change. Delta H is heat change. Enthalpy is the heat change of a reaction. And in any reaction, we have exothermic or endothermic reaction. In exothermic reaction, heat is given out to the surrounding, while in endothermic, heat is absorbed. So delta H is heat change is equal to heat content of product minus heat content of reaction. If the heat of the product is positive, if delta H is positive, it means the heat content of the product is more than that of the reactant. This implies that after the reaction, the product is very hot. It shows that it has absorbed heat. Heat is absorbed. So that shows that it is endothermic reaction. Meanwhile, when delta H is negative, it means the heat of product is lesser than that of reaction. So it is exothermic reaction. Heat is given off. And in exothermic reaction, in the product, the reactive vessel gets warm because heat is given off to the surrounding. While redox reaction is a reaction in which oxidation and reduction is taking place. In oxidation is addition of oxygen, reduction is removal of oxygen. Oxidation is removal of hydrogen, reduction is addition of hydrogen. Oxidation is removal of electron loss. This is electron gain, reduction. Oxidation leads to increase in oxidation number, while reduction leads to decrease in oxidation number. And this is under radioactivity. They say that if uranium changes to thorium this way, what has occurred? It simply means that it has released an alpha particle, which is a helium nuclei, like I explained. So when this guy gives off alpha particle, it becomes this guy. So look at it. 235 is equals 231 plus 4. They can as well so this one has given 2 electrons, 2 here, so it becomes 90. In some cases, they will say let here be Y, and they will put S here. Here will be S. They will ask you to look for Y and S. It's very simple. In reaction, mass is not destroyed. It just changes. Since mass is not destroyed, this place simply means that 235 is equals 231 plus Y. Here also means that 92 is equals 90 plus S. So S is equals 2, Y is equals 4. So alpha particle has been released. And this is the evidence of particle nature of matter, kinetic theory. It shows that matter behaves as particle. Matter can also behave as wave. So we have wave nature and particle nature. So the proof that matter behaves as particle is Brownian motion, random motion of a body, diffusion, movement of particles from a place of higher concentration to lower concentration, osmosis from lower to higher concentration through a semi-permeable membrane, evaporation, change from liquid to gases when the heat is applied, then dissolution. In fact, even sublimation, they are evidence of the kinetic theory of matter. Why this says that E is equals mc square. So binding energy is equals mass defect times the speed of light, and the speed of light is 3 times 10 raised to the power of 8. So these are homologous series. Homologous series. I explained alkenes, and alkynes. We have alkanones. They are alcohols. They are ROH. RO is an alkyl group. Alkyl group is formed when an alkane loses one hydrogen. I told you that the general formula of alkane is CnH2n plus 2. But this is CnH2n plus 1. So with the loss of one hydrogen. So that is anytime you see RO, you put CnH2n plus 1. So this is alcohol. It has OH functional group. Alkanones, CHO. This RO is the alkyl group. Esters, RO, RO prime. So alkyl, 2 alkyl groups and O in the center. So that is ROCOOH. ROCOOH, this is acid, alkanoic acid or carboxylic acid. Alkyl group and COOH, that is acid. They end with COOH. While alkanones, they have RO2 alkyl group and CO. They end with CO. So that is it. I hope it has been amazing so far. If you really enjoyed this class, why not subscribe for more videos, and why not check out my other videos? So part 2 of this video will be released soon. So thank you, you are the best.